everyone. So today we're going to continue our discussion of finding the area of a triangle. Last class you guys learned Heron's formula to find the area of a triangle. You guys use this formula when it's a side triangle, or you know all three side lengths. And remember, S is just standing for, S is just standing for something called the semi-perimeter, which is just half of the perimeter of the triangle. So you find the perimeter of the triangle, divide it by 2, and that's S. And then you can just plug in A, B, and C, which are the three side lengths of the triangle. And then obviously you guys remember the formula for area of a triangle that you guys learned back in middle school. Today you guys are going to be talking about a third formula for area of a triangle. So you use this formula when you have a situation like this triangle below. Obviously this triangle you couldn't use Heron's formula because you don't know this third side yet, and you don't know the base and the height of this triangle either. So you can't use the middle school formula. So if you were given this triangle, you would be able to use law of cosines to solve for that third side. And then you could use Heron's formula, because if you found that third side, you would know all three sides. You could find the semi-perimeter and use Heron's formula. But there's a different formula that we're going to be talking about today that you can use that would make this problem a little quicker to solve. So this formula is called, I don't know if it really has a technical name, but I call it finding the area of a triangle using sine. So the area of a triangle equals half the product of the lengths of any two sides and the sine of the angle between them. So just like law of cosines, you guys can see that this formula has three different forms, and these three forms are just assuming that you're using a triangle ABC. So I'll label that triangle above as triangle ABC, and then we can think about which formula would be helpful here. So based on how I labeled that triangle ABC, you could then label each side. And remember, matching letters have to be going across from one another. So I said that 10 was side B because the angle across from it, I call it angle B. All right, so now we can see that the two sides that we know in this triangle above are B and C. And so we're going to use the formula that have the product of B and C. And notice that that is helpful because that pairs us with sine of angle A, and we know angle A. So we're just, if we wanted to solve this triangle, which we are going to do for example 1, we would just ignore these other two forms of the formula. If I had labeled my triangle a little differently, I could have ended up using this second form or this third form. Formula. All right, so example 1. Notice this is the same triangle as the previous page or slide. And remember, all of our assessments are open notes now, so you guys can have the formulas written out. But notice all forms of that formula on the previous page, you're using all three letters in the formula. So if you're using half the product of B times C, then you're going to be pairing that with sine of angle A. All right, so now we can just substitute everything into the formula. Our area of this triangle is going to be 1/2 times the length of B, which is 10, times the length of C, which is 12, times sine of 30 degrees. All right, I challenge you to pause this video and take a second to think about what this product would be without using your calculator. So go ahead and pause the video. I know you guys remember the unit circle and you know what the sine of 30 degrees is equal to, and you guys can solve this on your own. All right, so remember sine of 30 degrees is equal to 1/2, and so when you substitute that into this expression on the right-hand side, you get 120 divided by 4, or 30 units squared. This triangle didn't have any units, so I just Remember, area is always units squared. Example 2 is the same kind of idea. This is a side angle side triangle. I don't think we really talked about that in the first example, but you do use this formula with side angle side triangles. Not that you can't use Heron's formula, because like I said on the previous page, we could solve for this third side using law of cosines. So it's not that you have to use sine here to find the area, but that is going to be the quickest way to find the area when you're given a side angle side triangle. All right, so take a minute to pause this video and work out this example 2 for yourself. All right, so here's the worked out solution to example 2. I did label my vertices a little differently in this example just to kind of mix it up. So you guys might have used a different form of the formula based on how you guys labeled your vertices. But when you do take half the product of the two side lengths times sine of the included angle, you get 9.5, and then whatever the units are squared. So that's the area for example 2. All right, and then lastly, I want to talk about when you're not given a side angle side triangle, how you guys can still use this formula. So notice in example 3, we're given a triangle ABC with 2 sides, and then this angle. Remember, we haven't really been using this, so maybe I'll change this to just say capital A. So this angle that's given has to be opposite side A. We haven't really been harping too much in online learning on Greek letters, so we'll stick with what we've been doing and use a capital letter to denote the angle measure. All right, so if this is a triangle with those sides, call A 5.0 centimeters, we'll call B 3 centimeters, and then angle A has to be the angle across from side A, and that's going to be 37 degrees. So take a second to think about what kind of triangle this is. Hopefully you guys can see that this is a side-side angle triangle. You have 2 given sides and a non-included angle. Remember, non-included angle just means the angle not between them. All right, so what's so special about side-side angle triangles? Yes, the ambiguous case. So it would be important to think about what this triangle looks like, because if this is the ambiguous case, if there's 2 possible triangles that can be drawn here, they're going to have different areas. So remember, you need to know all the different cases of the ambiguous case, but in this specific example, when the opposite side is longer than the adjacent side, there's only one possible triangle that exists. So there's only one possible area for this given triangle here. So in order to use sine to determine the area, we're going to have to find the measure of the included angle up in here, because that's what the formula involves. It involves the product of 2 sides and then the sine of the angle between them. So how could we find this angle measure in here? Well, we could use law of sines to find this angle measure over here, and then subtract those 2 angle measures from 180 degrees to find this third angle measure. So let's do that. I'm going to go ahead and label this angle on the left angle B because it's opposite side B, and since it's triangle ABC, my third vertex needs to be labeled C. All right, so using law of sines, sine of angle A, which is 37 degrees, over side A equals sine of angle B, which is what we're going to solve for, over side B. So you guys can cross multiply there, and you get 3 times sine of 37 degrees equals 5 times sine of b, which means sine of b has to equal 3 times sine of 37 degrees over 5. All I did was just divide both sides by 5. And so then measure of angle B is going to be equal to sine inverse of that ratio, or that fraction there. And when you plug that into your calculator, sine inverse of 3 times sine of 37 divided by 5, I get 21.17 degrees. All right, so then what's the measure of angle C? Measure of angle C is going to equal 180 degrees minus 37 degrees minus 21.17 degrees. So when I put that in my calculator, I get 121.83 degrees. All right, so now lastly, plugging this all in to the formula. We now know the included angle measure is 121.83 degrees. And so we're going to use the formula 1/2 AB sine C, because we know the length of A, we know the length of B, and we know the measure of angle C, which is the included angle between those two sides. When we substitute all our known values into the equation, one half times 5 times 3 times sine of 121.83 degrees, we get an area of 6.37 centimeters squared. So that's our area. And that isn't how you would have to find the area of that triangle. Again, you could have solved for this third side, and you could have used Heron's formula. But that was one way to find the area. So you guys should be set up now to do the homework and find the area of any triangle that we throw at you guys. If you guys have any questions, please email your teacher. We are happy to help you all.